Hello everybody, good morning. Myself Dr. Mahadev Pandge from Dayanand Science College Latur. I would like to discuss teaching material for a BSc first year student. So let's start with the syllabus. BSc first year course structure and marking scheme. In first year we have two semesters, semester first, semester second. In each semester we have to learn, we have to go for two papers, that is paper 1, okay, mechanics and properties of matter, that's paper 1, and this another paper, mathematical methods in physics, that's called as a paper 2. These two paper we have to study in a first semester, and consequently in second semester we have to study heat and thermodynamics, third paper, electricity and magnetism is a fourth paper. Each paper has have two credits, okay. So ultimately when you finish this first year, then you will gain 4 credits with 8 credits from the papers, 2 semesters, okay, and some 4 credits from the practical examination. So all that's a 2, 8, and this 4, this 12, okay. So 12 credit you will gain after completion of this. So mechanics and properties of matter, okay, this is the first paper which have some objectives. So these are the objectives: mechanics and properties of matter, paper 1. So what are the objective? Objective means like why this paper you wanted to study, or student wanted to gain, what they will gain from the paper. The objective of this course is to introduce the students to the world of mechanics. Okay, the world of mechanics. Okay, the objective of this course is to introduce the students to the world of mechanics and properties of the matter that exist in different phases, that is solid, okay, liquid and gas. Laws of motion and its application to various systems studied in this paper is of fundamental nature, okay, and enable the students to handle different types of problems, and is a prerequisite for the several other advanced courses in physics and chemistry. So not only in physics but also in chemistry these laws of motions were applicable. Okay, the prerequisite for this course is a knowledge of calculus, wave theory, and of course the modern physics. This course is a core course and very course is a fundamental, okay, fundamental course, and every student pursuing BSc with physics as one of the optional is required to this course, study this course. Fine. So under the contents under the paper 1. So in paper 1 you will have 4 chapters. One is the mechanics, unit first, unit second, surface tension, unit 3, viscosity, unit 4, elasticity, and these are the recommended books. Recommended books for this course, that's a element of properties of matter, general properties of matter, mechanics. Okay, D.S. Mathur, who is the author, and G.S. Upadhyay, and mostly the elements of properties of matter by D.S. Mathur is a frequently used book for BSc course. So let's go with the unit first, mechanics. In mechanics, we will learn these many points, okay, and of course these points for the we have to cover all these points within a 12 periods. Fine. Laws of mechanics, Newton's laws of motion, okay. Newton's first law of motion is called as a inertia. It's called as a inertia, and object will not change its motion. What exactly mean by the Newton's first law of motion or inertia? An object, okay, say object 1 and object 2 will not change its motion unless acted on by an unbalanced force. Okay, if it is at rest, who? The object. It will stay at a rest. Who? Object. Object will stay at a rest position. If it is in motion, okay, it is in motion, it will remain at the same velocity. Velocity is a constant velocity. Say if object is moving with say 3 kilometer per second, okay, then it will be always constant in 3 kilometer per second unless and until we are not applying any unbalanced or external force on it. Once you apply external force, then it will change its velocity. Earlier it was 3 kilometer per second. Now it may be because of applied force, it may go to the higher, like 4 kilometer per second or whatever the number is. Okay, but that is what we need to understand. But see that number from 3 kilometer per second to 4 or 5 kilometer per second, it not came immediately. It came because of the applied force. So this is what is called as a Newton's first law of motion, where object will change his velocity when we apply a external force. Otherwise, it will be at the same velocity which he is going to be. Okay. Or let's say, consider another case. Object is at rest. It is not having any motion. So it will remain in rest position unless and until you are not applying any external force. Okay. So object with greater mass have more inertia. This property which opposes change in motion. It takes more force to change their motion. Okay. Which more force for what? For a bigger object. Okay. This object has 300 kg weight. Okay, this object has 30 kg, so this object is 10 times bigger than this one, so it will take more force to change his position. Similarly, we have to understand the laws of first law of motion with the some example, like first law applied to the stationary object. So in this, we consider this is the case, object is stationary, fine, okay, and the similar law can be applied to the moving object. See, here the object is in motion. So this is the direction of motion. This is object, and this arrow tells us that it is in a motion. Okay. So this is just for a visualization. You have to go through it. Now, so second law. So the second law of motion states that what? Newton's second law of motion states that acceleration is produced when an unbalanced force acts on an object. What do you mean by this? Acceleration is produced. The main concept is, main thing is acceleration. Okay, acceleration is produced when an unbalanced force acts on an object. So here object is having some mass. Okay, the more mass the object has, the more net force has to be used. What we have seen in an earlier example also, if the massive object is there, then we will require more force to change his position. So in a mathematical form, how we can write it? F force is equal to mass into acceleration. Okay, so this term acceleration, okay, this acceleration will produce when an unbalanced force, this unbalanced force act on a object having a mass, say m. So this is the Newton's second law. That's very clear that so force is equal to mass into acceleration, or acceleration is nothing but force divided by mass. So let's go towards the third law. This is Newton's third law. If body A exerts a force F, okay, force F on body B, okay, this is body A exerts force on body B, then body B also exerts an equal but opposite force on a body A. If A is acting or exerts some force on B, then the same time B is also exerts some force on A. So the both things, these things written in mathematical form. Likewise, see here you can see clearly FA, force A on B. This A is indicate that force because of A on B. Okay, this A body exerts force on B, and similarly in opposite direction body B, okay, force virtue of body B on A body. So this can be written as, because see here we have said that an equal but opposite force. Okay, so it's equal but opposite. So this minus sign indicates that opposite force. Okay, it's a counter force on a FBA on A or FA on B. So Fa means A, force A on B, this is force B on A. So similarly, there will be the what counter, opposite side, opposite force they will exert on each other. Okay, let's see summary of this law. Newton's first law of motion. Okay, what already we have seen it. Every object will continuous in state or rest or with constant speed in a straight line unless acted upon an external. So every object will continue in a state of rest, or state of rest means it's a rest position, or with a constant speed, that is in motion, unless acted upon a external force. See Newton's second law. So the second law, what we have seen, as I told, that acceleration will produce when force act upon a unit mass or a massive object, right? So when a net force act on object, fine, object is there, a net force acting on an object, the object will accelerate. Okay, it will change its velocity in the direction of net force. See, object is like this, you are applying the force, okay, like this, then the direction of the force, okay, it will accelerate, and the acceleration is directly proportional to the net force what you are applying and inversely proportional to the mass. Fine. Newton's third law of motion. Whenever an object exerts a force on a second object, okay, so what we have seen in the previous slide, body A acted force on body B, and similarly body B acted force on a body A, and that is the what in the form of opposite, okay, opposite direction. So thank you very much for understanding the Newton's laws of